So here we're in pressure control on the Servo U. And the nice thing about this ventilator is it will scale your waveforms automatically. So depending on what your patient data is, it will scale these waveforms automatically. The same things apply on the 840 we talked about to the Servo, in that, for example, I've got a little bit of a curve here to my pressure waveform. Utilizing my rise time to tell you a faster rise, I need to decrease that number. So look what happens now to my pressure waveform. It's a little more vertical, right? I mean, it's hard to tell. It's very, very minute changes, but that's clearly more appropriately scaled than it was when I was here. All right, look at this difference. See, obviously that's a little more leaning. So we can optimize our rise time. Trigger on this machine. Again, it's nice so you don't have to remember, okay, as I decrease my number, is that going one way or is that going the other? This will tell you what will make it less patient effort or more patient effort. So as my flow trigger goes down, I am making it less effort for the patient. You may even get into a auto cycling situation if I will tell the machine I want to do something that we shouldn't. It should self-cycle here. So again, this is a situation in which the machine is too sensitive and we're in a auto cycling situation. So I need to make the machine less sensitive. So I'm going to increase my flow trigger. And much better. So again, rise time and flow trigger on the Servo U. Some quick little things that you may have forgotten about this machine that I think is nice is the disconnect suction. So, for example, if I want to give my patient 100% oxygen whilst I'm taking them off to do whatever, so now it's saying it's giving 100% pre-oxygenation and it's waiting for me to do my thing. I'm getting my tools together and I'm going to disconnect the patient. So I don't have to do anything else with this machine as far as silencing it or giving it 100% because the machine's doing all of this. I disconnect my patient. Okay, the machine senses that and it goes, we're disconnected. I don't have any alarms going off. I don't have to worry about pushing any other buttons. Do what I need to do. When I automatically connect the patient back, the machine goes back into giving 100% post-oxygenation and again goes back into ventilation without me having to start anything. So that's a nice feature that sometimes we forget is there. Also, something that's really nice is if we tell this machine how many kilos the patient is, it will populate this box down here with cc's per kilogram, breath to breath. It's very useful, and I see many times that we're not using it. So what we'll do is you highlight the little guy up here, and it's telling you, all right, what are you dealing? What gender are you? Male or female? All right. And then in Epic, you can hover over the BMI, and it will tell you the height in meters. You just can move the decimal point 2 places, convert meters to centimeters, And for example, let's say we're 170 centimeters. It's telling you now my patient is 66 kilos of ideal body weight, and currently the breaths that we're giving are 6.6 cc's per breath. It's very useful when a physician comes in and goes, why are we on this volume? Why are we on this pressure? How many cc's per kilo is the patient? It's very easy to see. Oh, well, we have a 66 kilo male here, and currently we're getting 6.6 cc's per kilo of ideal body weight. So use the tools in which we have to make it better for the patient overall. Nice little feature as well, if you're ever in a situation and something's happening and perhaps you want a second opinion as far as what this waveform's doing, you can always take a picture right there. I just took a snapshot of what's going on. If I go to if I go into media, and I see right there, that was the screenshot in which we just took. Another nice little thing too is if you want to take a video, hit the video button. I've just taken 15 seconds prior to me hitting that button video, and I'm taking 15 seconds after. So it's a total of 30 seconds that's now going to record, and when it is finished, I go back into media, recordings, and here I see what's going on. And what's nice is we can cursor over, and at this particular minute, at that point, my peak pressure was 27, my flow was 0, and my volume was 435 cc's. So it's a great tool to capture maybe something that you have questions on, and then we can view it at a later time. Very helpful. So although kind of difficult to show on this lung that we have, the pressure volume loop can also show us changes in lung compliance. As the lung becomes less elastic, or in other words, you have a decrease in compliance, the loop will look more flat. It will start to lay down to the right. So if this is in fact pressure, it makes sense then if it takes more pressure to put the same amount of volume in, this whole thing is going to start leaning over this way. And if I can try to mimic that on this lung, you may see that that waveform move to the right a little bit. So as our lungs become more stiff, your pressure volume loop will start laying over to the right, indicating that it's taking more pressure for the same amount of volume. And then if we have a sudden increase in compliance, the waveform will stand up straighter. And so we can see that in one instance, so again, it's kind of difficult to see, but that's a little more vertical than it previously was, indicating a change in compliance. Also on our pressure volume curve, if you start getting a duckbill here, that's indicative of overdistension. So on the bottom here we have the flow volume loop. Volume is along the horizontal axis, and flow is along the vertical. And during inspiration, there is an increase in flow, which leads to an increase in volume. And during expiration, a decrease in flow leads to a decrease in volume. The flow volume loop can be used to see changes in flow following the effects of bronchodilators. And furthermore, on the expiratory side of the flow volume loop, the line should be smooth. If they're not smooth, this could mean that there's perhaps buildup secretions or perhaps water in the vent tubing, or something is causing a fluttering effect. And that's kind of what I'm mimicking here, as now these little guys are not so smooth as they were before. Hopefully you suction the patient, alleviating the issue.